Hi everyone, this video series is all about SAT math hacks where we discuss smart tricks and strategies to solve SAT math problems. In this video, I am going to talk about SAT math hack number 3, make your own substitutions. Let's see what this means. Here's our first question. Which of the following expressions among the 4 given to you is equivalent to this expression here? 7 by 7x plus 2 minus 1 by x minus 1. Which of those 4 expressions is equivalent to this expression? So, the typical traditional way would of course be to simplify and manipulate this expression and see which one it becomes equivalent to, but we will make our own substitution. What we will observe is that whatever expression this is equivalent to, if I substitute any value of x into this expression and the equivalent expression, I should get equal values. And the simplest substitution is generally x equal to 0 or x equal to 1, simple values of x. So, if I substitute x equal to 0 in this expression and in its equivalent expression, I should get the same value. So, that is the hack. So, if I put x equal to 0 into this expression, what do I get? So, this x becomes 0. So, in the denominator 7 times 0 is 0 plus 2. So, I get 7 by 2 minus 1 by this x is again 0. So, 0 minus 1 is minus 1. So, I get 1 by minus 1. So, 7 by 2 minus 1 by minus 1, which will be equal to 7 by 2 plus 1 or 9 by 2. So, if I put x equal to 0 into this original expression, I get 9 by 2. So, all I need to check is which of these 4 expressions will give me a value of 9 by 2 if I put x equal to 0. So, let us see, if I put x equal to 0 here and here, I will get minus 1 by 2 times minus 1. So, that will give me minus 1 by 2 times minus 1, which is equal to 1 by 2. So, this won't work. If I put x equal to 0 here, I will get 6 by, this becomes 0 and this becomes 3. So, 6 by 3, that is equal to 2. Again, it is not 9 by 2. So, this does not work either. If I put x equal to 0 here, I get 7x becomes 0 and then I have a 2 here and then this is 0 and I have a minus 1 here. So, I get minus 5 by 2 times minus 1. So, that is 5 by 2 and once again it is not equal to 9 by 2, and then finally this one should be it. If I put x equal to 0 into this, I will get minus 9 in the numerator and then this is 0 and I get a 2 here and a minus 1 here. So, 2 times minus 1. So, that is minus 9 by minus 2 or 9 by 2, and that is what we wanted. So, this is incorrect and therefore, this option is correct. So, we did not have to manipulate the original expression. We just substituted x equal to 0 and we found that the value of the original expression at x equal to 0 is 9 by 2, and then we just checked which of these 4 expressions will give us 9 by 2 for x equal to 0. So, that is the hack. Here is question number 2. Which of the following expressions is equivalent to this expression here? So, we have this expression here and then we have 4 expressions and we have to find which of these 4 is equivalent to this. So, once again, if you do it the traditional typical way, this would be fairly lengthy. You would have to do a long division of this cubic polynomial by this linear polynomial and then figure out what is the quotient and what is the remainder and so on. And obviously, we will be smarter than that and we will make our own substitution. So, once again we will substitute x equal to 0 here and let us see what we get. So, if I substitute x equal to 0 into this expression, this becomes 0, 0, 0 and I get a 9 in the numerator. In the denominator I get 0 plus 1, so that is 9 by 1 or 9. Now, I will check which of these 4 expressions will give me a 9 if I substitute x equal to 0. Alright, so in option A, if I substitute x equal to 0, I get a 0 here, a 0 here, and then I get a minus 14 here, and then I get a minus 23 by 0 plus 1, which is minus 23. So, here I get minus 14 plus minus 23, which is minus 37. So, this option does not work. Now, substitute x equal to 0 in option B. So, I get a 0 here, a 0 here, a minus 14 here, and then 11 by 0 plus 1, which is 11. So, I get a minus 14 plus 11 here, which is minus 3. So, again this option does not work. So, I will cross this out as well. Then let me go to option C. I put a 0 here, 0 here, and then minus 14 here, and then plus 23 by 0 plus 1. So, this one will give me minus 14 plus 23. So, this one works. So, let us just see if option D is giving us a different value for x equal to 0. So, I substitute x equal to 0 here. I get 0, 0, and then a 14, and then a 5 by 0 plus 1 or 5. So, this one's giving me 14 plus 5 or 19. So, this one does not work as well, and therefore, the correct answer is option C. So, you can see how simple the solution became just by using the substitution x equal to 0 and not even bothering with the long division of these polynomials. So, that is the hack, make your own substitution. Let us look at question number 3. Which of the following is equivalent to this expression here? And once again we have 4 expressions here, and we have to find which one of these is equivalent to that. So, once again we will make our own substitution. So, let us substitute x equal to 0 first and see what this expression gives us. So, we have minus 3 times 0. So, the numerator in this first term becomes 0. So, the whole term becomes 0, and then here I get a minus 7 by 0 minus 2. So, that is minus 7 by minus 2, which is equal to 7 by 2. Now, let me check which of these 4 is giving me 7 by 2 for x equal to 0. If I put an x equal to 0 here, I will get 21 in the numerator, and in the denominator I will get this is 0, this is 0, this is 6, and then this is minus 2. So, 6 times minus 2, and this will clearly not be equal to 7 by 2, because if I simplify it, I will get a 3 times 7 is 21, 3 times 2 is 6. So, this is minus 7 by 4 in the simplest form. So, option A is ruled out. I need a 7 by 2 for x equal to 0. Now, let me put x equal to 0 here. I get in the numerator, this becomes 0, and then I get a minus 21 in the numerator, and in the denominator I get 0 minus 0 plus 6. So, I get minus 21 by 6, and in simplest form this is minus 7 by 2, but I need a 7 by 2. Okay, so, option B is also ruled out. Now, I go to option C, put a 0. So, I get 10 times 0, that is 0 plus 21. So, in the numerator is 21, and denominator is 0 minus 0 plus 6. So, 21 by 6 or 7 by 2. So, this could be a potentially correct answer, and then I look at option D as well and put 0. So, I get 0 plus 21 in the numerator. So, that is 21 in the numerator, and in the denominator I get 0 minus 0 plus 6. So, 21 by 6 or 7 by 2 again. So, there are 2 expressions here that are giving us the value 7 by 2 for x equal to 0, and either of them could be potentially correct. So, let us take another value of x and find this expression's value, and then see which of these 2 is giving us the same value for that value of x. So, I will take another simple example for x. Let us take x equal to 1. So, generally 0 and 1 are the 2 simplest substitutions. So, I will take x equal to 1 and I will substitute it into this expression. So, I get a minus 3x or a minus 3 in the numerator by 1 minus 5 plus 6. So, 1 minus 5 plus 6 is 2. So, I get I get a 2 here, and then I will have minus 7 by 1 minus 2. So, that is minus 7 by minus 1. So, this is equal to this thing here becomes a plus 7. So, 7 minus 3 by 2 or 11 by 2. So, x equal to 1, for x equal to 1, this expression's value is 11 by 2. Now, let us check which of these 2 expressions will also give 11 by 2 for x equal to 1. So, if I put x equal to 1 here in this expression, I get a 10 plus 21 or a 31 in the numerator. So, let me write it here, and in the denominator I will get 1 minus 5 plus 6. So, that is 2. So, I am getting 31 by 2. So, this option is therefore ruled out, and then let's just check option D. I put in x equal to 1 here. So, I get minus 10 plus 21. So, that is 11 divided by 1 minus 5 plus 6, that is 2. So, I get an 11 by 2. So, option D is the correct answer in this case. So, here we made our own substitution once again, but we had to make two substitutions because for the first substitution, we got two possibly correct expressions. So then we did another substitution and then we found the correct answer. All right. The next question says, which of the following expressions is equivalent to 8x cube minus 27y cube? And then you have four expressions here. And if you look at the structure of this expression, it's the cube of something. So 8x cube is 2x whole cube minus 27y cube is 3y whole cube. So this expression is of the form a cube minus b cube. So you could of course take the traditional way and factorize this, apply the algebraic identity for a cube minus b cube and figure out which of these is the correct expressions. But once again, since we are learning a hack here, we will follow that and we will make our own substitution. And it's very possible that sometimes you might forget the algebraic identity involved and so on. So the hack here will always work. So in this case, once again, we will substitute specific values for x and y and see which of these expressions will also give us the same value for those values of x and y. Now, if I take x and y as 0, then this whole thing becomes 0, but so do all of these expressions. As you can see, if I put x and y as 0, all of these expressions values will become 0. So that substitution won't really work. So in this case, I will simply substitute x and y both equal to 1. So this one here will give me 8 minus 27, which is 8 minus 27 is minus 19. So let me now check. So minus 19. Let me now check which of these four expressions is giving me minus 19 for x and y equal to 1. So for the first one, I get, so now I'm just substituting everywhere x equal to 1 and y equal to 1. So I get 2 minus 3, which is minus 1, times 4 minus 12 plus 9. So 4 plus 9 is 13, minus 12 is 1. So that's minus 1 into 1. That's not really, what do we need? We need a minus 19, and therefore option A doesn't work. Now in the second option, we have 2 minus 3, that's minus 1, times 4 plus 12 plus 9. So that's 16 plus 9 or 25. So minus 1 times 25. So this one also does not work. We need a minus 19. Yes. Now what about option C? So I have 2 minus 3, that's minus 1, times 4 plus 6 plus 9. Okay, so 4 plus 6 is 10 and 9 is 19. So minus 1 into 19, that's minus 19. So this could be possibly correct, but let's also look at this expression. So that's 2 minus 3 minus 1 times 4 minus 6 plus 9, and that is 7. So that's minus 7. So this one's ruled out, and therefore option C is correct. So once again, making our own substitution, x equal to y equal to 1 helped us figure out the correct answer. Now question number 5, if n is a positive integer, which of the following expressions is equivalent to this sum here? So this sum 1 square plus 2 square plus 3 square up till n square is the sum of the first n perfect squares, and we have to find out which of these expressions is equivalent to this sum. And once again, if you remember the formula for the sum of the first n perfect squares, this is actually fairly straightforward to do, but you may have forgotten it, you may not remember it on the day of the test. So what you can do is just make your own substitution. So in this case, we can take a very simple value of n. The simplest possible value of n we can take is of course 1. We just take n equal to 1. So we just get the first term of the sum, 1 square, and then we see which of the four expressions is also giving us the same value. 1 square is 1. So we want an expression that gives us the value 1 for n equal to 1, but we will find multiple expressions here that will give us that value of 1 for n equal to 1. So what I'm going to do instead is I'm going to take the next value of n, which is 2. So I'll take n equal to 2, and for n equal to 2, my sum s is 1 square plus 2 square, which is equal to 5. And now I will just check which of these expressions is giving me a value of 5 for n equal to 2. So if I take n equal to 2 here, I get 2 times 3 by 2. So this is 3, and therefore option A is ruled out. If I put n equal to 2 here, I get 2 times 3 n plus 1 is 3, times 2n plus 1 will be 2 times 2 plus 1, which is 5. So, 2 times 3 times 5 by 6. So, this is equal to 5. So, this could possibly be correct because I want the sum to be equal to 5. Now, I will put n equal to 2 here. So, I get 2 times 3 times 5 by 2. So, that will be equal to 15. So, this is ruled out. And if I put n equal to 2 here, I get n square, which is 4, and n plus 1 square, which is 9, 3 square is 9, and divided by 4. So, this one will give me 9, and therefore, this one is also ruled out. And therefore, the correct answer is option B, n times n plus 1 times 2n plus 1 by 6. Now, this particular question, once again, if you happen to remember the formula for the sum of the first n squares, then this is very easy to pick right away, but you may not remember it, and therefore making your own substitution helps here as well. All right, here's the next question. The first term of a sequence is 7. Each term after the first is 3 times the preceding term, and if t represents the nth term of the sequence, which equation gives t in terms of n? Now, once again, you may apply your mind here and logically figure out what the formula is going to be. But in this case, what I'll do is just make my own substitution again, and I will just observe that t is my nth term and n is my index that tells me the position of the terms in the sequence. So, if I just take n equal to 1, the first term, I already know that that first term should be equal to 7. So, for n equal to 1, I should get my term equal to 7. So, all I need to do is check which of these expressions do I get t equal to 7 for n equal to 1. So, if I put n equal to 1 here, I get 7 times 7 to the 1 is 7. So, 3 times 7 is 21, and therefore, this is incorrect. I need t equal to 7. If I put n equal to 1 here, I get 7 to the power 1 minus 1, which is 7 to the 0, which is 1, and then 3 times 1 is 3. So, I am getting t equal to 3 here, which is again incorrect. If I put n equal to 1 here, I will get 3 to the 1 is 3, 7 times 3 is 21. So, I am getting 21 here as well, which is again incorrect. And now, if I put n equal to 1 in the last one, I get 3 to the n minus 1, 3 to the 0, which is 1, and therefore 7 times 1 is 7. So, I am getting t equal to 7 here, and therefore option D is the correct answer. So, once again, you did not need to figure out the whole thing. Just by making this simple substitution, n equal to 1 should give you t equal to 7. We are able to figure out that option D is the correct answer here. All right, here's the last question of this lesson, and this one is a bit wordy, so I'll just quickly read through it. Rosa opened a savings account at a bank. The table shows the exponential relationship between the time t in years, so that's one variable in years since Rosa opened the account, and the total amount n in dollars in the account. If Rosa made no additional deposits or withdrawals, which of the following equations best represents the relationship between time t, which is in this column, and the total amount in dollars, which is in this column? So, time t, this is t and this is n, and we are given 4 equations here, and we are asked to pick which one represents the relationship between n and t. So, once again, what will we do? We will make our own substitution. We will just observe that if I put t equal to 0, I should get n equal to 604. So, let me just check which of these relationships is actually doing that. So, if I put t equal to 0 in this first relationship here, this thing becomes 0. So, this whole bracket 1 plus 604 to the t becomes something raised to the power 0, which is 1. So, that will give me n equal to 1, and therefore, this won't work. If I put t equal to 0 here, that is doing exactly the same thing again. I am raising something to the power 0 here, and that will again give me 1. So, option B also won't work out. If I put t equal to 0 here, then this thing here is being raised to the power 0. So, this whole part of the expression will become 1, this much here, and then that is 1 times 604. So, I will get n equal to 604 here. So, this could possibly be correct, but let us also check this. If I put t equal to 0 here, I get this whole thing here as 1 times 0.004, so that's 0.004 which doesn't work, and therefore option C is the correct option. So we did not even have to go through the hard work of figuring out the relationship from here. Just by making this substitution, t equal to 0 should give n equal to 604, we were able to figure out the correct relationship among the options given. Now, one call out here is, of course, you are able to do this only because there's a limited set of options given and you need to pick out the right one from that limited set of options, but that is what the test is about. So this hack helps you get to the right answer much faster, given that you have only a limited set of options to choose from. So that was the hack. Make your own substitutions. I hope you liked it. Let me know what you think in the comments. Thank you.